Hi guys, this is Gabriel from TechClick. SpaceX Resupply mission will help island's crew study a whole lot of science experiments as we'll outline in this video. Please sit back and enjoy. Remember to hit the like button and subscribe too. In January 2015, SpaceX Falcon 9 rocket and Dragon spacecraft launched from Cape Canaveral Air Force Station, Florida, for their fifth commercial resupply CRS mission to the ISS. Dragon returned to Earth 4.5 weeks later. Commercial space service. SpaceX's Dragon spacecraft is scheduled to make its 14th commercial resupply mission to the International Space Station on behalf of NASA. The Dragon will be atop a Falcon 9 rocket and is scheduled for liftoff from Cape Canaveral Air Force Station in Florida no later than 4:30 p.m. Eastern Time on Monday, April 2, 2018. Delivering a payload of 5,800 pounds (2,630 kilograms) of supplies, equipment and scientific research to the ISS crew. Some of that cargo will facilitate scientific research on a dizzying array of subjects, ranging from the effects of severe thunderstorms on Earth to growing vegetables in space. It also will help the space station's crew to test new materials in industrial processes in the harsh environment of space, and to evaluate a new medical technology for healing battlefield wounds. Here are a few of the experiments being delivered by the mission. Experiment 1. Growing veggies in orbit. The resupply mission will enable ongoing research on growing food such as tomatoes, cabbage and lettuce in space. The Veggie Passive Orbital Nutrient Delivery System. An experiment will study a new way to deliver nutrients to plants. Tupperware, a manufacturer that is more familiar as maker of those handy containers you store leftovers in, and TechShot, a space hardware company, has been involved in development of the system. Experiment 2. Metal powder fabrication. Another experiment being transported on this flight will allow astronauts to study a process known as liquid phase sintering. NASA compares it to building a sand castle on the beach with sand that's just wet enough to stick together, but instead of sand, liquid phase sintering uses metal powders. On Earth, sintering has applications in making automobile engine connecting rods and lubricating bearings. But the ISS crew will be looking at how the process works in the microgravity of space, with an eye to someday using it to erect buildings for a lunar base or manufacturing replacement parts for space vehicles and equipment during extraterrestrial exploration missions. This illustration shows the variety of upper atmospheric phenomena powered by thunderstorms. The SpaceX flight will deliver the Atmosphere-Space Interactions Monitor, an orbital observatory that will study severe thunderstorms. Experiment 3. Investigating thunderstorms from above. The SpaceX flight will deliver equipment for the Atmosphere-Space Interactions Monitor, an orbital observatory that will study severe thunderstorms and their role in the Earth's atmosphere and climate. From its vantage point in orbit, ASIM will gaze down upon exotic phenomena such as sprites, those mysterious bright flashes that occur in the mesosphere, a region about 31 to 53 miles 50 to 85 kilometers above Earth's surface. ASIM also will observe blue jet lightning, which shoot upward as far as 12 miles 19 kilometers into the sky from the top of a thunderstorm cloud, and ELVs, which are donut-shaped light flashes that span for miles. Experiment 4. How well materials work in space. If you are going to send a satellite or a spacecraft into the cosmos, you want to know in advance whether the stuff that it is made of will survive the harsh environment of space. The Materials Islands Experiment Flight Facility will do just that. It is designed to test how well coatings and other components perform when exposed to the high levels of radiation, heat and cold, bombardment with charged particles and even collisions with micrometeoroids in orbit. Experiment 5. Drug research. Just because a drug has a certain effect when taken on Earth, that does not mean that it will work the same way in space. This experimental project has an unwieldy moniker, Comparative Real-Time Metabolic Activity Tracking for Improved Therapeutic Assessment Screening Panels, but the idea behind it is a lot simpler. Metabolic tracking, as it's known for short, will allow the crew of ISS to study the effects of microgravity on the metabolic effect of 5 different pharmaceuticals. Experiment 6. Fixing wounds. On battlefields back on Earth, There is a continual struggle to find ways to keep soldiers alive after they suffer increasingly horrific wounds caused by today's high-tech killing technology, or from infections that develop before they can be evacuated. That is where NanoRac's Module 74 wound healing might save a lot of warriors. The experiments will test a patch containing an antimicrobial hydrogel that promotes wound healing even as it acts as a scaffold for regenerating tissue. That is something no existing bandage can do. Thank you for watching. If you actually enjoy this video, please drop a like and a comment. Also subscribe to this channel for frequent science, technology and education videos. Thank you.